All righty, we're going to do this next problem where we sketch the graph and then of y equals ln parentheses x minus 1. We sketch the graph and then we answer this question. What's the limit as x approaches 1 from the right of ln parentheses x minus 1? And I think that really this is a bit of memorizing the graph of logarithm. And the graph of logarithm is very similar to the graph of log base 2 of x. But I think it's something that you can just try to commit to memory. And so what are we looking for? What I'd say you're looking for is a vertical asymptote, which is the x-axis, increasing, and then that the intercept is x equals 1, which means y equals 0 and x is equal to 1. And then it's increasing. And all these logarithm graphs, they increase very slowly. What I mean, all of these, I mean, regardless of the base, whether it's base log base e, log base 1. So this right here is not our final answer. This is y equals ln x, which means y equals log base e of x, and e is around 2.7, roughly, sort of really roughly. It's an irrational number. And okay, so that's that graph. So what I see is a vertical asymptote. I see it's increasing. Now, what will happen to the graph of a function, regardless if it's logarithm? What happens to the graph of the function when x is replaced by x minus 1? What happens to the graph? Well, the whole thing is shifted to the right. We shift to the right. So the graph of y equals f of x, well, let me not do that. Let me just say the graph of y equals ln x minus 1 is a shift right by 1 of y equals ln x. So I'll just do the same graph. Actually, I could even just do like a duplicate here on this thing. No, we only did part of it. And when I do this, though, I need to, I believe, the right way to do it is to make sure I put a dotted line for a horizontal asymptote there. Sorry, I said horizontal, vertical asymptote. Always a question. Can I talk and write at the same time and think? Okay, so the vertical asymptote is is something I can see. It's x equals 1. It's a line x equals 1. And that leads to us answering this question. What is the limit as x approaches 1 from the right? Well, it's built into this idea of vertical asymptotes. It's all fits in there together. What is the answer then? The answer is that it's equal to negative infinity. That negative infinity corresponds with vertical asymptote and the graph going down, 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 which means that if I pick a value of x close enough to 1, but still greater than 1, then I can make this y value of y equals ln x minus 1 as large as I want, large being negative in this case, large negative number, like negative a billion, just one number that's big and large and negative. Okay, so anything else to say about that? Any questions or comments?
Thanks for doing this.
Oh, okay, well, let me end this video first. second.